P block, 15th group. 15th group consists of nitrogen, phosphorus, arsenic, and bismuth. Nitrogen is a gas, while phosphorus is a wax solid. These are semi-metallic solid. This is metallic solid. Metallic solid in the sense size is bigger, so outermost electrons are not very well caught up by the nucleus. That means they can interact with electrons of the other atoms of bismuth. So metallic bonding is prominent over there. Metallic bonding, we learned in deep level that interaction of unpaired electron is called metallic bonding. Atomic number 7, 15, 33, 51, 83. Now, outermost electronic configuration 2s2, 2p3, 3s2, 3p3. And here when it comes 3d10 is 2. Here 3d 0. 3d 0. Outermost electronic configuration 2s2, 2p3, 3s2, 3p3. Now here, when we here 3d is 0, but when we reach here, our side, that is 3d10. Here 4d10, then that time here 4d 0. When it comes here 4d10, 4d is full. That time 4f 0. When we reach here 4 and 14, then 5d, then 6s to 60. See the variation. Here there is a 40 variation. Here only 10 variation. Here only 10 variation. And here 20 variation. Here 10 variation. So main variation what we are seeing is here 70 and 1. The main variation what we are seeing is with 70, 110. So this is why, see here only 10 variation, here only 10 variation. This is due to, you see when we come here, 4F, 5D, 4F there, shielding power is very less. 4F electron shielding power is very less. So outer electrons are very well attracted towards the nucleus. But here, when you consider this phosphorus and nitrogen, inner shells are SNP. Inner shells are SNP. S electrons or P electrons, they have no shielding effect. Compared to this B and F, their shielding power is very different. So note down the difference in atomic radii. The difference in atomic radii of N and P. The difference in atomic radii of N and P is comparatively large. Due to the effective shielding of S and P electrons. S and P electrons of the penultimate shell. Penultimate shell. When it comes to P, last shell is 3. Penultimate shell is 2. Penultimate shell contains S and P. Their shielding effect is higher. So inner shell, that is just inner shell, that is penultimate shell. The penultimate shell consists of S and P. But in the other case, penultimate shell D, penultimate shell D means where its shielding effect is very much. In addition to that, here in the case of bismuth, F orbitals are also getting fit. Next, we are moving to ionization. Ionization enthalpy. Night there is 1402 kilojoules per mole. 1402. Very high ionization enthalpy as compared to phosphorus 1012. As the size is increasing, so ionization enthalpy is 947, then 834 and 703 kilojoules per mole. See, nitrogen has got very high ionization enthalpy. You can compare it with carbon. Just for this nitrogen, we have carbon. Carbon's ionization enthalpy 108. 1086. So here, when we comes an addition of an extra shell is when we come from nitrogen to phosphorus, an extra shell is getting added. But such extra shell is not getting added when you move from carbon to nitrogen. Carbon and nitrogen, they are very much closer. Still, a very high ionization enthalpy. Of course, the size slightly decreased because of this, or the same, the electrons are added in the same shell. Electrons are added in the same shell, so Z effective is increasing slightly. But this variation is a bigger variation. Why? Because nitrogen has got half full stability. The P, that is Px, Py, Pz. In that, nitrogen has got half full stability. So to take one electron from this half full stability, we have to supply very high amount of energy. Now coming to electronegativity, nitrogen is an electronegative element. Nitrogen is an electronegative element in such a way that it can form hydrogen bonds. Only nitrogen, oxygen and fluorine NOF can form hydrogen bonds. Electronegativity of nitrogen is 3.0. It's highly electronegative. Fluorine is the most electronegative with electronegativity value 4. Metallic character, we have already explained that as we come down, the size is increasing. So outermost electrons are not held very much tightly by the nucleus. So they can interact with the unpaired electrons of the other atoms, other similar atoms. If you take one piece of bismuth, so many bismuth atoms are there. There will be metallic bonding. So bismuth is a met. Next. Allotropy. Nitrogen does not show any allotropy, but rest all are showing. Phosphorus, white phosphorus is there, red phosphorus is there, black is there, violet is there. But phosphorus, for us we have to learn white and red. Arsenic, gray, yellow, black, antimony, yellow and black. Next we are moving to catalysis. Self-linking property is catenation. In class 10 you learn carbon can show catenation. Carbon can make bonds with the carbon plus. Carbon, that's how this organic chemistry, the basic of organic chemistry, the carbon can form is catenation, show catenation, and it has got tetravalence. So carbon can form or carbon can show catenation. What carbon can show catenation? CC single bond is very strong. What about nitrogen? Can nitrogen show catenation? Nitrogen N single bond is very weak. N triple bond is very strong. But for catenation, single bond is required. Single bond is required. So nitrogen, for catenation, you have to consider the strength of this N single bond. We are considering nitrogen, phosphorus, arsenic, antimony, and this. N single bond is very weak due to the interelectronic repulsions because of the small size of nitrogen or the nitrogen small size. Of the nitrogen small size. So what happens? Around one nitrogen, lots of electron. In that small size means electron density is high. And the second nitrogen also electron density is high, smaller the size. So there is interelectronic repulsion. So due to that interelectronic repulsion, why interelectronic repulsion? Due to the small size. So this N single bond N is very weak due to the interelectronic repulsion because of the small size of the side. So N single bond N is not possible. So nitrogen will not able to get. But phosphorus size is bigger. P single bond P is single bond. P single bond P is stronger because of the bigger size. No interelectronic repulsion. So phosphorus can undergo catenation. Means phosphorus P4. You know that phosphorus exists as P4, but nitrogen exists as N2 only. Rest of AS4, Sp4. So here, this phosphorus can undergo catenation. That's how we have P4. Phosphorus, 4 phosphorus atoms, polyatomic, 4 phosphorus atoms make this single bond. There is no carbon components. Here, only phosphorus atoms are there. 4 phosphorus atoms. Similar to the case of arsenic and nitrogen cannot undergo catenation. Why? Because N N single bond is very weak due to the interelectronic repulsion because of the small size of nitrogen. Phosphorus. I told you phosphorus P4. P4. There are four types of phosphorus. You have to learn white and red phosphorus. White and red phosphorus. Here, white phosphorus exists as this P4 discrete units. P4 discrete units. But red phosphorus exists as a polymer. It exists in the polymeric form. How? This is one P4 molecule. Another P4 molecule. Another P4 molecule. These P4 molecules these P4 molecules are getting connected to form a polymeric. So one electron from here and one electron from here, they make a bond over here. So here another connection. Similarly, one electron from here, one electron, that time you don't show this bond. Okay. So one bond. Similarly, one electron from here, one electron from here, make a bond over here. So red phosphorus exists as a polymeric form, while white phosphorus exists as a separate molecule. So, due to this polymer formation, red phosphorus is stable. Red phosphorus is more stable than white phosphorus. So, write down the differences between red and white phosphorus. White phosphorus, poisonous, highly reactive, exist as discrete P4 units. Exist as discrete P4 units. It glows in dark. It glows in dark. That's right, red phosphorus. Non-poisonous. Non-poisonous. Less reactive. Less reactive. It exists as a polymeric form. It exists as a polymer. It exists as a polymer. It does not glow in dark. So 4 points. There are only one sentence answers are asked. There will be 5 questions or 8 questions from this chapter. Each 1 mark, 8 marks. Write one question. Nitrogen is a gas while phosphorus is solid. Nitrogen is a gas while phosphorus is a solid. Gas means in the molecular form, N2 and P4. N2 is very small, size is small, but P4 is bigger in size. Right down. N2 is smaller, N2 molecule is smaller in size, while P4 is bigger. N2 molecule, gas means gas consists of molecules. N2 molecule is smaller in size, while P4 molecule bigger. So in N2 molecule, less van der Waals force of attraction between the molecule. Small, so surface area is less. So less van der Waals force of attraction between N2 molecule. But in bigger phosphorus, since the surface area of the P4 molecule is large, there is strong van der Waals force of attraction. Strong van der Waals force of attraction. Next question. P has greater tendency to catenation than N. Why? P has greater tendency to show catenation than N. Why? So that same answer, that is nitrogen does not undergo catenation while phosphorus can. Answer is what? N single bond N. N single bond N is very weak. N single bond N is very weak due to the interelectronic repulsions. Due to the interelectronic repulsion because of the small size of nitrogen atom. Because of the small size of nitrogen atom. Because of the small size of nitrogen atom. While in P4, not like that, right like this. P single bond P is stronger. P single bond P is stronger as phosphorus atoms are bigger. As phosphorus atoms are bigger. Next heading, nature of both. Whether they can form covalent bonds or ionic bonds. Two portions. A, by electron transfer. By electron transfer. B, by electron sharing. By electron transfer. Nitrogen 2px1, 2py1, 2pz1. So from other species, it can take electrons, one electron from outside can come to one electron from outside can come to this orbital. One electron from outside can come to this orbital. So nitrogen will show -3 oxidation state. When it takes 3 electrons, nitrogen will show -3 oxidation state. So nitrogen atom has a tendency to accept 3 electrons because it has got high electronegativity and smaller size. So it forms, we can say Mg3N2 can form Mg3 or Ca3N2. So its valency oxidation state will be -3. Oxidation state will be -3. So it can make ionic bonds. Next, by electron sharing. By electron sharing. By electron sharing, nitrogen can form, you can say, ammonia. Phosphorus can show phosphine. Then PCl, ammonia is irregular. And N triple bond N by electron share, N triple bond N or P4 by electron share, P4 by electron sharing. So by electron sharing also they can make bonds. Now nitrogen, phosphorus, arsenic, antimony, bismuth. Maximum covalency that nitrogen can show, that is 4. But nitrogen can lose 5 electrons if a more electronegative element comes closer to it. So nitrogen 2s 2p 2s2 2px1 2py1 2pz. In 2, in the valence shell, there is no d orbitals. 2d does not exist. But the case of phosphorus, in the case of phosphorus, 3s2, 3s2, then 3p, 3px1, 3py1, 3pz1, and there are 5, 1, 2, 3, 4, 5. 3d is empty. 3d is empty. So, in the case of phosphorus, it can promote one electron and make its covalency 5, but that facility is not available in the case of nitrogen. So, nitrogen can show a maximum covalency 4, while phosphorus can exceed its covalence. Thank you.